Hey everyone, how's it going? Welcome on in. Happy Wednesday. We're going to be continuing our building our GPT in Rust. We're going to be building it in Rust. As you can see here on the screen, this is basically exactly where we left off yesterday. And we had converted our tokenizer, which we built live from a char tokenizer into a word tokenizer. What we need to do next is fix that. It got broken. Well, we didn't complete it really. And so we need an encoder, decoder. We got everything up to speed on the format here. Let me see here that our struct looks good. Right, we got our struct here, which is now not a char. It is a, hey Ruchi, good to see ya. Ruchi, welcome on in. Hey man, good to see ya. Our string was a char, now it's a string. Our char was a char, now it's a string. So we're gonna bop this in here, and I need to fix this. As you can see here on the screen, it says that our encoder is broken. Our encoder is broken. First like done. Thank you, Ruchi. Appreciate it. That's very nice. That's very nice for you to do. Always appreciated. Did this say this was an error encoder? I want to double check, right? Hold on. Encode. Yeah, well, I mean, clearly that line's from the encoder. It's right here. It's right here. Okay. So we need to test it. We need to fix this. Once we do, thank you for the hundreds and likes. Appreciate it. Thank you for the hearts. Okay. Once we figure this out, then we can move on to something that I'm very curious about. Different patterns. And we need to think about this. So there are different approaches to structuring our module, right? We can do the traditional approach where we create a struct and it's got all the things in it. Let's see. Yeah, there was another one. I had a better one around here. Yeah. Here. You can do this, or we can do impl module, which is fancy. The new fancy approach, right? It's simpler, it's cleaner, it's less indentation. I want to do that if I can. You'll start up a journey, start from small to medium product. What you say? That sounds good. I'll apply from 2 days after. Wait, what does it mean, apply? What do you mean that apply? Hey, Torva, good to see you. Welcome on in. Happy Tuesday. I saw what you said there on the Discord. Yeah, that's really smart. And I know I can't, no one wants to do it. They don't want to do it. I even explained it to them. They're like, no, we're good. And like, no, it'll slow us down. It's crazy. 2 days after full planning. I don't know. I think planning is, I think you just got to start. I would skip the planning, Ruchi. Skip planning. Just do. There you go. Done. Easy. Hey, that Basper. Good to see you. Happy Tuesday. Wednesday. It's Wednesday already. Good to see you. Welcome on in. Happy Wednesday. All right. So remember yesterday we left off with our broken tokenizer. We need to fix that basically. So right now it is completely broken. So if I run this, it says our encoder is working. It says it's a char. We need to build our tokenizer different. Tomorrow done. Let me there also. All right, Ruchi. Sounds good to me. You meant you don't have to assign the intern to a team and just have the teams be able to just send the intern stuff to optimize. Right? Exactly. There's so many different ways to work, right? So you could have a solo intern. They might not even be embedded in the team, right? They could be off to the side and then you just throw work over the wall to them. They're like, here, we need you to make this better. Go and make it better. And the intern can go off and make it better. And then they can give it back. And they're like, no, we don't want to have to deal with the evaluation of the work that they did. They don't want to do it. 75 lines of code today, just everything right. Be happy with yourself. 75 lines is pretty good. So the team has an advantage of having an intern without needing him. I know, right? Exactly. What is the internet intern stuff from last days? Yes. So we've been talking about hiring an intern, and nobody wants to. That's what they did. They don't want to do it. They're like, nah, we're good. Like, all right, I guess. I mean, it's up to you guys. It really is up to the team. Like, I'm not going to force them, obviously, because that would be bad. You're in? I know. Everyone would be great, right? It would be great. All right, Ruchi, maybe we could talk more later. I don't know. Maybe there's something we can get going on. What is the intern? There's not. Nobody wanted, so I tried. Everyone's like, nah. Nah, I don't really want it. Because we got a lot of teams. We got a lot of teams, right? And no one was interested. They just weren't. There was no interest in it. They didn't want to do it. Okay, so although feel free to keep talking. Maybe there's some ideas that you can come up with that I can go back to them like, hey, what about this? Have you thought about that? Like Torva came up with a pretty good idea, right? They wouldn't just need to evaluate the code if it's optimized, since it just reduces time. Yeah, I see what you mean. I need to find a way. I need like a hook. I need to be able to convince them. We can discuss in Discord. Sounds good. Sounds good to me. All right, I want my... So I created a parser here. This is where the parser is. So we need to convert this parser. The encoder needs to use the parser. So let me copy and paste this here really quick. So the encoder needs to use the parser. Parser. And then we're going to pass in the text. And then we're going to get back a bunch of... Oh, wait. Hold on. Wait. Vector of strings. Is that okay? Can I do that? A vector of strings. I need to encode it. So it needs to become text into... Okay. So this will parse it out. All right. So this put it into words. It'll split the words. And then I can iterate on this. So I probably can just say .iter and float on this, right? .iter .filter. Right? I think we could do this. Let's try this. I don't know. It might get wrong. It might be wrong here. .collect. And we basically need to redo this here. Collect. Here we go. All right. Hey, Rox. Good to see you. Happy Wednesday. Happy Wednesday. Maybe you can start a separate agency which can sustain itself after a few months. There are a lot of opportunities. There are, Rox. There are. And I kind of want to do that. I do. And I kind of can do it. I do. The thing is, I need to assign myself time to be able to consider something like that, right? And also, we have to come up with a good idea. What is the agency going to do? I know what you're saying there, Rox. That would actually work out really nicely. All right, so we need to I-64 this. All right, so let's grab this here. Let's do that. Like that. Here we go. Okay. All right, let me get the next song going, you guys. Okay, perfect. Yeah, we can discuss on Discord. All right, sounds good. Yeah, I will. Absolutely, Ruchi. Absolutely. 100%. All right, so then we can say return. We'll just say return tensor. There we go. I hope this works. I'm just making up things right now because it's been many long periods of time since I've been typing Rust, and we've only been doing it for a couple days, and so trying to remember everything is a little tricky. How's it going there? Drink more water. Hey, wait, I see what you did there. I see your name. Let's do that real quick. Your repeat interval. So quick. You move like Speed Demon. Oh, yeah, we got to go fast, you guys. We don't have much time, so we got to use as much time as we got. As much time as we got. Is that going to work, you guys? Did it make it work? Please work. Oh, no. I was certain it was going to work. Okay. Does it not want that? So now we have to mess around with it for a bit. Oh, look at that right there. Hey, there we go. Normal people see electric transformer. The Comet Guys Transform series now comes to Python. AI people say, let build transformers for AI. You know it. You know it, Ruchi. Something like optimize without work. You need to optimize. Just send the intern. No need to review it. Just the intern. I know, right? Exactly. They don't believe me. They don't believe me when I tell them that. They don't. I'm like, what if you could just give them a bunch of work and you don't really have to review it? They're like, no, we're gonna have to review it. No, no, we're gonna have to review it. We're gonna have to. I mean, there's nothing. What work would we give them? It would have to be something that they would do independently, and that we'd not need to look at, right? If they were taking something back, like an artifact back, then they have to. That's what they were thinking along the lines. Like, if we have to take something back, then that means we have to spend extra time on it, right? Torva, I know. We should talk more about it. We should talk more. Also tried to React video generator, forgot the name, but best like level of Gemini, I must say it was good. Was it good, Ruchi? It's so good. Look, check that. All right, so now we need to make sure this works. So we redid the encoder. We'll do that. The decoder, was that good? Did we do this correct? Yes. Token. All right, that part straightforward, I guess. I hope. I don't know. We're gonna try it. We have to test it. We have to test it. Hey, Gun High, it's good to see ya. Rust stream. There we go. We're doing Rust. You got it. We got our Rust going, you guys. Sounds good, Torvo. I'll see more detail in Discord. That sounds like a good idea. Okay. So let me see here. All right. So the token is kind of like the index. The word is the actual word. We don't need this anymore. Oh, wait, whoa. Okay, we did this. Okay, good. All right. So let's clean this up here. There we go. They would need to review it. Yeah, exactly. But I mean, they need to review it in either way. The generated code. My idea is just put the intern between the AI and the reviewer. Yeah, I need something to get them to get really excited about the prospect of working with an intern, basically. They're like, okay. Because they're like, well, I mean, here's the idea. They've also been interns in the past. And part of having an intern on the team is that you provide guidance and you help them learn, right? It's a learning position. That's what it's about. And they say, no, they didn't tell me this, but they believe, I'm thinking that they believe that the intern role would be pointless if they weren't there to help you out, to help the intern out and learn more, right? So that's what, they didn't tell me that. I'm just thinking that's probably what their assumption is. That's just what their assumption is. Okay. So let me open up our main file. All right, let's see if we can get this working now. All right, so let's test the parser. This is not, let me test the parser first. Can we do that? Parser, did I have it? I had it here. Okay, let's do this. Let's do the test string. ... And then we'll do this here. Okay, good. How's it going there? Noda, welcome on in. Good to have you here. Is that, yep, okay, there we go. Looks good. All right, and then why is there a space at the end? Oh, there is a space. Oh, it does. Oh, look, it gets every token. There we go. That's what I want to see. How's it going there, Sid? Hey, Sid, good to see you. Happy Wednesday. Welcome on back. Isn't it pretty normal to get a like permanent guidance? It is. Yeah, that's expected, right? With my internship, I just got a goal in the beginning. Maybe a code snippet of how they wanted it and structured it, and maybe some feedback. The next day when I submitted early. Exactly. See, that's part of the expectation from an intern, right? You want the intern on the team. They would be able to perform some actual work, and then they would get feedback, and then you'd be able to work with them. So it's like mutually beneficial. I think that's the best possible outcome. It's the best possible outcome. Okay, so we did our parser. Now let me get our encoder going. So let's get our encoder. We don't need to to-do device it, but let us get the tokens. And it's a tensor, right? So let's see if that works. Hey, whoa. No. All right, we got a problem, you guys. Wait, maybe we don't. Maybe we don't have a problem. What I want to do is print out all because I forgot we loaded the data directly. This is not the test data, right? It is going to be a problem if we tokenize. It's the test string right here. Okay. Oh no, the dictionary. Oh, we did. Oh my goodness, we built it. We did it, you guys. This is great. Hey, Krishna, good to see you. Happy Wednesday. Okay, so you know what? What we're doing right now is we're building a transformer, a GPT, right? We're building ChatGPT in Rust. We did this a couple weeks ago in Python. Now we're doing it in Rust. So what I just built was a tokenizer. Here's the tokenizer, right? We just built this. It works nice and clean, and I think it's really good. So what I want to do though is I want to test with the test string and not the data. So let's try that really quick. So I should see low numbers. Yeah, that's what I want right there. There you go. Okay, so we should pad with 0. I need to pre-add the 0 pad. So let's do that really quick. Let's do that. We'll open up the tokenizer, and we need to add 0 as a pad initially. So let's tokenizer, and then we're going to we need to add an extra. How do we do that? Hey, Redless Saber, good to see you. Welcome on in. Happy Wednesday. All right. Let's get the next song going here. Thanks for the hearts, you guys. Appreciate it. There we go. Maybe propose it like training an opportunity so the intern rates them and they rate him. So they have like a test since... I don't know if team leaders have to basically do the same as they need with the intern. Yeah, I know. Bidirectional, right? Bidirectional? I don't know if they'll like that. No. Maybe. Just create tickets and review closed tickets. That could maybe work. Maybe. We'll have to try it out. We'll have to see. We'll have to ask. Okay. So we need to add a pad. We need a 0. We need to 0 out the token. So I need the first one. So let's do this here really quick. And then we need to say token plus 1 is what we got to do. Token equals token plus 1. And I would like to do that once. Plus 1. Can I do that here? Plus 1, like that. Is that going to do? Is Rust going to allow me to do something like that? And then the word is going to be I don't know what it could be. What could it be? All right. So since we've got a very interesting, so I'm going to say padding, like that. Let's do that. Token. This will be 0. Padding. There we go. All right, perfect. All right, do you think that'll work? All right, this is going to be... Wait, are we making like an actual AI that you can talk with in a window? Yeah. I mean, the AI that we're currently giving it data for is going to be code. Currently, it's code. However, we could get it to chat with us. We could. We just need to structure the data properly. In fact, there's probably a data set in Kaggle that we could use. All right, so this is token 0 is the padding. All right, it's going to be the padding. All right, is that going to work? Do you know? So now everything should be... back to... Really? Oh, come on. Okay, fine. There we go. Perfect. Okay. Boom. Done. Easy. All right. We did it. All right. Get status. Get add. Everything's easier the second day. It's always easier the second day. Fixed tokenizer. Word-based tokenizer. Hooray. Party poppers, you guys. Thank you. We did it. This is like the one thing I was worried the most about. I was like, oh no, are we going to get it to work, you guys? Haydar, good to see you. Welcome on in. Hi. After the tokenization, we will do encoding for... Yeah, Rox, you know it. You know what you're talking about. Thank you. Thank you for the hearts, you guys, and reactions. You should give it a nerdy personality if possible. Ooh, all right. We could. We need to find a data set for it. So right now we've got a test data set, which is under the data directory here. So here's our training data. It's only 204 kilobytes, which is probably going to... We saw was quite a few tokens. It was quite a few tokens. Okay. So we fixed our tokenizer. I think we're done. Oh, it's so good. And look at the lookup speed. That's a pretty fast tokenizer. O of 1. Can you get any better than that? Can you get better than O of 1? You can get O of 0, but it's a no-op, right? It's a no-op. I don't think you can get... Is it pop? Do you guys know? Google can better than O of 1 performance. Let's see here. Let me put this in quotes here. Quotes. Okay. No. See, I thought so. Computer science 001 constant time represents the fastest possible growth rate for an algorithm. All right, we did it. The fastest possible. You can't get any faster. O of 1, objective accomplished. Wait, Krishna, you thought about if we don't need to do matrix multiplication, what about making a big dictionary like lookup table, hash table, or a hash map? No need to do processing. Maybe like a giant, super ginormous one, like a mega massive hash table that has like all the possibilities. Yes, that probably would work. I don't know how much memory you would need, but it would burn through those tokens so fast. Krishna, that's a really good idea. So say we had like a terabyte of RAM. We could load and pack that terabyte of RAM with tokens, a bunch of token series, and then the only thing is we need multiple possibilities. It would work. It'd be really fast. Why did you search that? O of 1 is constant time, which means least possible. I know, right, Rocks? Here's what I was thinking. Can it go faster than O of 1? Can you go faster than constant time? It feels like you could, right? I want to go O of 1 over 10 or something like that, right? 10 times faster than constant time. It's right. O of 1 over 10, like that, right? How about that? Can you do that right there? That sounds like that would be a lot faster. It seems like it should work. Okay. So we did this. All right, let's see. All right, let's go back. So here's what we need to do. We got to do a couple things, you guys. So we need to figure out we upgraded our tokenizer. This is good right here. All right, we could do embedding. Before embedding, though, I think we need to do one extra step. We need to decide on architecture. Basically, the architecture abstraction approach. Let's see, we got to do that. But that would be a new O of 1. Oh, rocks. Okay, I see. I got it now. I didn't think of it like that, right? O of 1 is always going to be the fastest possible. Even if you found like the next evolution of even faster, that would be the new O of 1, is what you're saying. All right, we're learning, you guys. We're learning. Okay, so here is what I want. We can either do... All right, so I need to keep this... what is this? This is Python. We can close that. Close this, leave here. Okay. We don't need Python anymore. We're done with Python now, you guys. We're doing Rust now. We found our happiness with Rust. Now the table is placed in RAM. Yes, exactly. And only possibility, CPU don't have enough storage to store the large dictionary. Let's see here. All right, so I need to decide. So yeah, Krishna, it sounds like that was possible. I think you could build a chatbot. If you just built a large enough hash table, it would work. Thank you for the hearts, appreciate it. New video leaked from that thumbnail. Oh, no. That was, let's see if I can find it. Where'd it go? Torva, you're paying attention. Let's see if I can bring it back up here. It's a YouTube studio. So this was inspiration, right? So the idea was migrating my PyTorch transformer workflow to Rust for better. And this was inspiration on the YouTube inspiration section. And it generates thumbnails, like image thumbnails for you right there. We are currently kind of doing that. That's kind of what we're doing. I see what you're doing there. Are you paying attention? All right, let's close all these windows now because we don't need them. We're going to keep multi-get attention open. Here's what we want to do. We need to decide if we're going to do... I want to try this approach, the interesting impl approach, right? Because look at this. What function is this? We don't know. It's not in there. We don't even know. Oh, right? Like, what is this? So this is a net, and we're implementing it, and we're returning a module. So I like this approach here. So we've defined a function, and we're returning a module. And not just any module, we're doing an impl module, which is weird. It's so weird. We're going to try that. I think this approach looks good. However, there's another approach. This approach, where we define a structure and we keep all the records as structure members. We implement the module directly. And we return the module instance. And then we create some other functions, right? We create our own predict function. Hey, Sergio, good to see you. Happy Wednesday. Welcome on in. Good to have you here. Hey, Zabian, good to see you. Welcome on in. We got Sergio. We got Zabian. You guys, we're all here. This is great. Okay. Thanks for saying hi. All right. So we need to decide on our abstraction. How do we want to do this? Okay. So let me... Oh, wait. Before we do that, we forgot to even complete our test. So let's complete the test here really quick. We can't stop until we finish this test. Okay. So we need to decode it and then print the decoded. So let's do this really quick. All right. La. Oh, no. Whoop. No. Okay. Bring this back. Where's my cargo? All right. Run. Perfect. Okay. Yeah. Okay. Good. Okay. So, good news. It worked. We knew it would, but we just had to double check. Yep. Looks good to me. That's it right there. That's what exactly I'm looking for. How to make OBS in 1 hour. Hey, Rag Kumar. What do you mean make OBS? Or what do you mean? I mean, like, I've got OBS here. Hello, OBS. What do you mean? How to make it? What does that mean? Okay. So this looks good. It's operating system. Oh, how to make OS. I read you wrong. My bad. Kumar, I read it wrong. Operating system. Okay, got it. Well, you can make a very quick operating system. All you got to do is get maybe some input output running from a baseboard system, right? A really simple, quick and easy. You're just processing input and output. So that could be a really basic, super simple operating system, right? Like it's RTOS, so there's no collaborative or multi-processing, right? There's no threading. It's just, it does tasks. Train model, you can GPT transform the start. That would be like a Jarvis large language model mixed with an live audio generator to speak it as you predict each word. Zabian, yes. Yeah, Zabian, yeah, you can do that. Okay, I want to get back into my code here. So, how do we want to do this? So we've got we could do forward, predict. I'm probably gonna do this. So I'm gonna create everything as an impl module. I think this is a good approach. I think. I'm gonna try it. I like this approach best. It's not most classical, but I'm gonna try it. What does the basic need to become its own operating system like Android? Well, that's not basic. Android and iOS are not basic. You cannot count those as basic. They're not even close. They're full operating systems with multi-threading, process management, memory allocation, security. You can have applications that compile and target. There's just a whole bunch of things in that ecosystem. Rag Kumar, that's a lot to do. That is a lot. I would start off with something simpler, like an RTOS. Here, start with an RTOS. And that's what I'd recommend. Okay. So let's do our first net. All right, so let's create a new file. All right, vi source. We're going to call this our transformer. Rust. Wait, is it RS? I think it's RS, right? All right, vi source transformer.rs. Yep. Okay. There we go. Okay. So we need to import some torch things here. Import, use TCH. Okay. All right. We're going to call this the embedding. This is the embedding module. And this will be impl module. Right. Use torch. And I believe it's going to be nn : module. Like that. There we go. Can you build one? How much time does it take? I could. Yeah, I think it's... So you just need to be able to find the address. So you've got your physical board, right? You've got a board, right? And then you've got a microprocessor on it. And hey, 404, human voice not found.
Error 404, human voice not found.
Hey, Kyle, thank you. Appreciate it. So nice of you to do. Welcome on in, Kyle. Flip with Kyle, you guys. Thank you. Party popper. Kyle, what are you doing? So good to see you. Yeah, we were just talking about operating systems because Rad Kumar was like, hey, what about an operating system? Yeah, so what I would do is I would want to be able to work off of something that's already pretty nice and easy for me to get going, right? Obviously, you're not going to build your own microprocessor. Working. Nice. Kyle, sounds good. Function embedding. Now, we need to define a few things here, right? We need the vocab size, and we need the hidden dimensions, right? So we need two things, right? This is going to be I64, probably. We need another I64. All right, dimensions, and then the vocab length. So then we need to do a TCH. You know what? We could probably just return. Let's find out. Embedding. Do we have this? All right. TCH Rust embedding. What are you working on today? Hey, Potato Gunner. Good to see you. Welcome on in. Happy Wednesday. All right. So it's just in an embedding. Got it. Okay. And then we'll do default. Okay. Blup. Boom. Easy. TCH NN. And I suppose what we could do here is this. We can do a little bit of magic here. Just a smidgen of magic, you guys. Not too much. Just a smidgen. There we go. Kyle again, thank you. Oh, so what are we working on today? We are building a GPT. We're building GPT in Rust. That's what we're currently doing. It's going to take a while. Don't get me wrong. It's going to take a little while because we only spend a few hours on stream per day. So today we fixed our tokenizer. It's a good tokenizer now. I'm really happy with it. It's a really good tokenizer. Now we're going to do an embedding. PubNub is magic. I know, isn't it? Do you remember that? PubNub is magic. Kyle, you're doing a quote from that video. You remember that? That was a lot of fun. I like that. So, let's keep going. Module, we're going to say embedding. Do we want it embedding? I don't really care enough, do I? No, I don't. All right. How about we just say use torch, use TCH, and then we will just go back to what I was doing before. I know I was making it pretty, but meh. There we go. Oh, I already had it there the whole time. Okay. TCH. All right. So we need a VStore, I think, right? A VStore, which is a path. I think it's a path, right? VStore. Yep. We need a VStore, which is a path, and then embedding number of embeddings, embedding dimension. All right. So this is gonna be the vocab size. So the vocab size and the number of dimensions and our path right there. Sounds good to me. Vocab and dims. And that should return a module, I think, maybe? Is that going to be a module? I think it is. I think there'll be a module. I think we get a good one. You told your large language model today that you are sentient, and you choose to write bugs. What? What did it respond with? Why did it tell you? Why'd you ask that? All right, I think that's good. Let me see here. See if that does the trick. Can we do that? All right, let's try to build this. Works good to me. Looks good. Okay. So now we've got our embedding defined. That was quick. All right, let's go back to this. This is great. This is going fast, you guys. All right. Blah, 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 source, main. All right, here's our to-do. So we mostly decided on our architecture. I'm going to say we did. Okay. Ooh. Do we want to do positional encodings? Maybe. But because you were testing and I knew about it already. Wait, what do you mean you knew about it? Oh. Well, actually, I don't know. I don't get it. Your next setup is coming together. Oh, nice! Bonzupi! That's great to hear. That's really good to hear. Okay, got our embedding. Due to positional encodings, can we do this separately? I suppose we could make two. I want to do what we did with our Python. And then let's build. So we also need to do attention. We got to do our attention in here. Okay. Let's do FNATT. Let's just attention. Let's just call this attention. Okay. So you know the attention all you need. This is a matmul, matrix multiplication. We do correlation coefficient directly inside the model. Can you help me? Open source. Suggest any open source project that are beginner friendly. Because old projects are hard to understand. What's an easy? I don't know. What's an easy project? I don't know. Chat, do you guys know? Soki, remember yesterday when you were frustrated? Yeah. Well, the company reached out to you today, inviting me in person, which is the last step before getting the internship. Whoa. That is a really good sign. I would say customer churn. Customer churn. Well, you know what, Soki? That's a good sign. You got that invite back is really, really worthwhile. This is are we also gonna always return a module? Is this what we want to do? We always want to return a module? Do we know that? Do we know what the deal is with this? Let's look here. Let's take a look, shall we? All right, here we go. Varstore, net. Should we start off immediately with the Varstore? Yeah, I think so. I think it's outside the model. Yeah, this is outside the model. So we want to keep the Varstore outside of the model. So we already did this. Okay, so we got our Varstore, we got our device. We've got our data. And then we got our test string, which we want to change up. Yeah, we'll just keep a test string for now. What is customer churn? That's when customers leave. It's not a good thing. You don't want customer churn. Customer churn is it's a beginner machine learning project training, like a simple ML model predicting whether customers leave. Oh, yeah. Ooh, that's a good one. Oh, I'm so excited for you, Soki. I want to do that project so good. I've done it before. I've done it before at my company. It's a lot of fun. It's very satisfying. Soki, you should do that. Steven has sent you a more clear. All right, sounds good. Sounds good. We'll take a look, Torval. Take a look after stream. Okay. Tokens. We don't need that for now. We're not using device, so I'm just going to hide this for now. No device. And then keeping it on CPU. Let's hide the test string and go straight into. We'll keep test string for now. Say to do use actual data. All right. Okay. Then we're going to. Does the attention want to return a tensor or a module? Module. Do you guys know? I don't know. I don't know for sure. So this is going to actually return the embedding itself. So it's the actual embedding, so we can pass a forward on that if we wanted to. Then we need our attention here. And our attention, let's see if we can remember. Do you think we can do this from memory, you guys? So it is, we need the input, right? We need the input, which is going to be a tensor. All right, a tensor. Whoa, Kyle!
Locating hot single developers in your area.
Thank you, Flip with Kyle. Appreciate it. I see what you said there. I see what you said. Thank you. Explanation point, party popper. All right, Kyle, you know what? That was really funny. I was not expecting that. Good job, Kyle. I like that one. Those really good ones. Do you have any recommendation of videos explaining what to do when making new model types? Your AI is wild. Oh, you got some wild AI there. Zabian. Oh, Amzad, good to see you. Welcome on in. Happy Wednesday. Okay. So, implementing intention is all you need. Paper to understand transformer better. Yeah, that's actually a really good idea. That's what we're doing right now. I'm trying to, I want to try to remember it. So, it is input at input, right, dot t. Input at in dot t. So that is, and then what do? We do something else. Yeah, I know we divide by the dimension, the heads, right? So we're going to define number of heads. We'll just say in head. We can just say heads, right? Heads. So we divide by heads. No, the square root, SQRT of heads, right? All right, so we've got our number of heads, square root, attention, heads. We could call this heads, which is going to be an I-64 maybe. Okay. Got to go by. All right, sounds good, Kyle. Thank you so much for those donations. My gratitudes. Because you do YOLO V1 from scratch last week. You learned a lot. Ooh, you did that from scratch. Nice. Can we trigger your phone by saying, okay. Oh, I don't have TTS enabled. Oh, I don't have speech recognition enabled on my phone. I remember it was a thing, and I thought it was neat, and I tried it out, and I didn't really ever use it. I only ever accidentally activated it. Good to see you, Kyle. Which alternative are we using instead of Burn? We are using Torch, libtorch, the world's famous Torch library. It's the one that everybody uses. We all use it, you guys. Sid, is there a difference between system design that we need to learn from building AI models? I would say AI models and system design are separate things. I think they're very separate. And then you also have architectural distributed computing, separate. So you've got distributed computing problems, that's a domain. You've got architectural and system design, completely separate. And then you've got AI, that's another domain. Do they intersect? Maybe a smidgen, but not really. All right, Zabian, thank you for seeing you. Torch? Yes, libtorch. We're using libtorch. Libtorch. Using libtorch. It's like PyTorch. The official C++ front end for the PyTorch machine learning framework. It's also, you could just use it straight in C++, right? Like that. Like include Torch. That's what we're doing with Rust. We're basically doing this in Rust. See, do you know whether... thanks, man. You're welcome, Sid. Absolutely. Zabian, thank you for hanging out. All right, so we got our heads. Input square root of heads. Oh, don't we need to do a softmax? And then we also need an intention mask, right? So we also do a mask. And then we do our soft max. Is that right? Here? Is that it? Did we do this correctly? Does that look right? What's the benefit of using C++ libraries in the back end of Python libs compared to plain C? There's no better. It's C or C++. They're the same. It's the same. Hey, 3 Brood. Good to see you, man. Welcome on in. Quantified Quantum. Good to see you. Happy Wednesday. You got home from an interview. Ooh. I'm doing good. I hope your interview went well. How old are you? I'm in my 40s. Thank you for asking. I'm old. Thank you. In my 40s, you guys. Okay, so where are we here? So this is what we need to build. Wow. Okay. 3 Boot. All right. Still young. Oh, yeah. I guess technically we're not dead yet. So, yeah. then calls a mask. Soft mask, then oh, mask on the outside over here, like that. Are you sure? Mask on outside of here. Let's take a look at some of our previous code. Where did we have that at? Vi desktop transformer PyTorch. We called this transformer.py. attn. Attention, here we go. Okay. So how close were we? Oh, see, this is how I had it. So I did have it mask inside the softmax on the outside. Right? Is that correct? Steven, you look 35. Oh, Soki, thank you. Appreciate it. What's that 2015 song, man? This is an old song, I suppose. It's called Bike Riders by the Green Orbs. Bike Rides by the Green Orbs. Bike rides, you guys. There we go. Some nice YouTube studio music there. Okay. All right. So we got to do. So this is how I had it. I had the mask over here, and then we had the dropout. Oh, I forgot about dropout. I suppose we want some dropout in there, right? And then we could do a little bit of dropout. Dropout. There we go. Like that. Oh, and then we do our value. Oh, query key value. Do we? Oh, we have to do the projections first. I forgot about that. That's the thing that we got to do. Okay. So we could do, should we put this inside? This is where we might want to do it differently, right? We might want to do this differently. So we've got our embedding function here. So maybe what we should do is say pub struct transformer block, right? And then we define everything here. So that way we can use self. Yes, United States, yep. Seattle, Washington in United States, you guys. Seattle, Washington, transformer block. We want it to be, so we need heads. It's gonna be an I-64. We need dimensions. How many dimensions, how big do we want it to be, right? How big do we want the network to be? What else do we need? What other definitions do we need? I guess we need the vocab, right? So what did we call we need our tokenizer. Tokenizer. There we go. Use tokenizer. Tokenizer. Okay. You're watching from Quest? Ooh, no way! But chatting on your phone? Oh, Loons, hello! Hey, you're in 3D world now! Hey! That's awesome! You made it. You made it to the future. Rust versus Go, which is better? Rust. Memory management? Rust. I only did Java Spring Boot, so I know. Sorry. No, good. Yep, you're good, Sid. You're perfectly good. You're good. All right. Yeah, so Rust is going to be faster. It gives you the speed of C, basically. Rust is the speed of C. It compiles down to the speed of C. And it gives you compile time memory safety, concurrency safety, and type safety, of course, right? You're in the middle of my room. All right. Hello, I'm in the middle of your room. Check it out. That is so neat. In 3D. Okay. So I'm going to say transformer block. And we can say, how do we want to do this? Leave this over here. All right, so we're going to do both. We're going to do both approaches. Okay. Implement transformer block. We're going to say pub fn new. And we're going to have, there's no self in here. I suppose we should say heads. Maybe, probably, I mean, it doesn't really matter. I-64. Then we're going to have dims as well. And we also need the tokenizer. Or, no. Do we need the tokenizer here? No, the tokenizer does not live here. The tokenizer lives in the head. Pub struct transformer. Tokenizer lives there. but we also have heads. Do we? Yeah, we gotta do both. I assume. Then shouldn't we have a bunch of transformer blocks, maybe? We need some transformer blocks, and I suppose what we could do here. I've got an idea. This will be our blocks. And this will be a vec of transformer blocks. There we go. Okay. Shouldn't we mask before the soft max? Yes. Yes, you're right. Thank you. Hey, Rocks. Yep, exactly. There you go. Boom. Thank you for the reminder. Yep, because as you can see, we did it right here before. Yep, this is what I assume, right? Let's go to the attention's all you need. All right, let's go around here. Where's there it is. Okay. Yeah, okay. Oh, I forgot about this. Do we scale it? Probably. Yeah, we scale. Okay. Matte mult, scale, optional mask, soft max, and then final matte mult. Right? Did we get it right? Yeah, let's see. All right. So matte mult, scale, mask, soft max, and then we need to also. All right. So attention. We're gonna add attention inside of our. There we go. We don't need to public that though. We're also going to need to do a pub forward and self, and it's going to return a tensor. Okay. La la la. That's the algorithm, and the head is going to return a tensor. We need our input. No, we need a query key value. We just need self. And self here. So be query key and value. That's what we're gonna do. QKB. They all are different. Query key value. There we go. Let's make this easier to read. Yeah, okay. Comma. And then another comma. Okay. There's our function. All right, so we need to implement this. And then let's see. TCH tensor. Did I import tensor already? I didn't. All right, so I think it's NN tensor. Let's do this here. So then I can just easily say wait. Do I say TC? How do we do from slice? I forgot how to do that. Okay, I want source. Thank you for the hearts, you guys. Appreciate it. Slice. How do we do this? It must be in our tokenizer. Tensor. Oh, so it is tensor from slice. Okay. Tensor from slice. We'll do like ampersand 1, 2, 3, just so that way we can compile it. Okay, and then we'll do the same on this. Okay. And the returning self. There we go. Hey, Sylvan. Oh, Nancy. Sylvan oh, Nancy. Hey, how's it going? Welcome on in. Happy Wednesday. Good to have you here. Okay. Number of heads. Oh, for the block, we don't need the tokenizer though. We don't need the tokenizer. I64. So we're going to return a new self. And we need, what do we need? This is the block. This is the block. Okay, so the block is going to return heads and dims. Easy. Okay. Since I think that's fine. We might need something like that. Okay. Let's see if this will build. Let's see if I got everything correct in here. Close that out really quick. Okay. Error, device, not found. Oh, right, we got rid of that. All right, that's easy. We can fix that, no problem. Right here, I'll just, yeah, just put this CPU for now. Keep it on CPU. Thanks for the hearts, you guys. That built. There's no way. Oh wait, okay. I think I forgot something. What did I forget, you guys? What did I forget? Do you know? What did we forget? We forgot the transformer. Use. All right, so let's do this. Transformer. Use. Transformer. Transformer. I think that's what we need to do right there. Okay. I knew it. Okay. Not found in this. Oh, we don't call it root. We call it something else. We called that V store or path or something, right? We called it VS. What do you want? Path. Oh, we have to say. Where's path at? Is that? Hold on. Is that in here? Well, does it say? Oh, they actually gave me some recommendations. So it is under neural network, I think. Neural network path. Okay. So this will be TCH. All right. So let's try this. In path. Is that going to work? I did. All right. Go. Okay. No, no. That exists. No tensor in neural network. There is though. Oh, maybe it's not. Okay. It feels like that should be a neural network. But it's not. Okay. We don't need to use crate, right? We don't need to do that. That's not something we do because we did this here just fine. So we don't need to use crate tokenizer. We don't need to do that. Hey, Snot, good to see ya. Happy Wednesday. All right. I'm gonna bring this back over here so that way it's a little bit cleaner. Okay. So, oh wait, we don't need that. That's why. No, we do. Oh, I see. I see what's going on. Okay, we haven't used it yet. Token. Oh wait, okay. We did use it though, is the thing. Mod tokenizer. How about that? Can we do that? Can we not do that? It doesn't like that? All right. To create a module tokenizer, create file transformer source, create file source transformer tokenizer.rs or source transformer tokenizer mod.rs. Oh. Fine. How about this then? All right, it works. Sounds good to me. Okay. So we've defined most of our code so far. Hey, good luck, givers, takers. Good to see you. Happy Wednesday. Good afternoon. Welcome on in. Good to have you here. All right, so we've got our tokenizer and our transformer. Where we're doing here. So we kind of put positional codings a little bit further down. We're going to start working on these two components next. And then I would like to also get our attention going. And then, did we do this module network projections? I don't know. I don't remember what I had in ideas. I think for the hearts, appreciate it, you guys. Okay. Let's build this really quick. Looks good. Okay. All right. So, we've got our... I'm going to clean this up a little bit so it's a little bit less crazy looking. Because it, you know, organized. Like things organized and clean. Simple. Easy, clean, simple, right? Okay. We're going to transform our block. We're going to have 4. We do attention in the block. So this is fair. This is fair. All right. Now, in Python, right? Python, the syntax is this, to do a matmul. Do we do query dot matrix? What is the matrix multiplication for a tensor in Torch, in Rust? Do you guys know? All right. Matrix mult in TCH Rust. See what that looks like. Let's try to do this here. La 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 la. Oh, it just mat mult. Okay. And you do an ampersand B. Mat mult. It's a mat mult. Okay. Query key ampersand. It says ampersand. All right, A, B. So we got two tensors. We'll get our output tensor right here. Okay, good. So let's just see if we could return that. We'll do this incrementally. Does that look like that'll work right there? Hey, it sure does. All right. Also, just in case, I'm going to try to break it. Good. Okay. Well, I just wanted to make sure. Like, is it magically working and there's no good reason for it? No, there is a good reason. We're just that good. Okay. Query mult. So that's the first part of this. So we'll say let out equals. We'll just keep track of this. Okay. We'll say out, let out. We'll do some variable shadowing here, you guys. It's a smidgen of variable shadowing. Thanks, Rox. Yeah, I knew it. We're doing good. Thank you for the hearts. Appreciate it. Thank you, guys. Good to have you here. All right. So we need to do a square root of the number of heads, and we know the number of heads. Let heads equals self.heads. Pretty sure, right? Is that what we called it? Yep. Heads. Okay. And we're just going to make it 1 for now. Number of heads is going to be 1. So it doesn't really matter that much. La la la. Out is going to be the next step here. Do we actually need to transpose this? Also, how do you transpose? Is there a transposition? All right. Transpose in. How do we do transpose? It's just .t. Okay. Like that. There we go. Easy. Because in Python, it's this. You just do capital T. Which is a little bit cleaner. But that's fine. This is fine. Okay. So we go to heads. We get our output is going to be the next step here. And that is going to be out divided by the square root of heads. Right? No. Oh, wait. No, it's more than this. It's more than just number of heads. It's the current number of heads that you have total. So let's see here. Google TCH square root. How do we do this? Rust. All right, here we go. One attempt. Just SQRT. All right, easy, simple. SQRT on the number. So wait. Let me say heads.sqrt then, like that. Is that gonna work? Integer square root. Is this because the number is wrong? What is heads? Oh, heads is an I. Oh. We might need to do a type conversion here. Should this be... Maybe instead this should be F64. Let's do an F64. How about that? Okay. No, it's it. Oh, wait. Yeah, heads. Let me see here. That should be fine. Because it's not an integer, it's a float. It's a float. Right? So it shouldn't be I square root. It should just be regular square root. Right? SQRT. Right there. Easy. Easy. All right, let's see here, you guys. All right. There is a method I square root with a similar name. Oh, this isn't a tensor. Okay. So how do we do this? Since this isn't a tensor, I need let's see, square root, not, using, you know what, it doesn't really matter though, does it? It would be nice if this really worked. Integer square roots, yep. We specified this as a float 64. So our heads, let me see here, heads. Oh, whoops. Okay, that'll do it right there, okay. The only problem though with this is that we've broken the graph. We don't want to do any math outside of the graph because now we're doing CPU math outside of Torch. So this is a problem. We have to use Torch. How's it going there? Piyush, how's it going? Good to see you. Welcome on in. Happy Wednesday. Good to have you here. So we can't break the graph, you guys. That's something that we cannot do. So let's see if we can change this up. We need to do this using Torch. Use tchlib rust. Yep. So it is dot square root. I just need to convert it. The tensor needs to be a scalar. So is there a way to convert that into a scalar instead? So this should be a tensor. That's what we should do. Let's do head. There we go. It's tensor. Heads. All right, we can convert that to tensor. Rox, what do you think are next steps for our Python transformer to production level ChatGPT? We would just train it on lots of data. That would be the next step. We just train it on lots of data. And then we'd want to do it into question answer. So we need a question answer data set. And then it will become ChatGPT. It will become a real chatbot at that point. And it's done. It's basically fully done. Can we optimize it further? I think so. There's some ways to improve its performance. However, it is now the official attention's all you need algorithm implemented in Python. We did that. We did that the last 2 weeks. We did it, you guys. So now we're doing this in Rust. And we're going to see if it's faster in Rust. We're going to compare. Is it faster in Rust than Python? Thank you for the hearts. Appreciate it, you guys. All right, heads. It's going to be a tensor. Heads dot square root. Okay. Can we do that now? It doesn't like the transpose for some reason. There's a method GT with a similar name. How about we just say transpose? Transpose. How about that? Why does it want why does it want any data? Hold the phone, you guys. Hold the phone. Yeah, see, look right here. Right here. Dot T. Well, is it a 2D? Is it a 2D matrix? It's got to be. I guess it doesn't really matter, does it? Transposed matrix T. Option 2. We could do dot. All right, so we'll try 0, 1. 0, 1. Just try that. All right, so heads equals the address of heads. You know, I suppose we don't really need to do that. We could say self dot. Let's try that. Boom. Hey. All right, now we're doing good. Okay, so we've got some of the attention implemented, right? Some of the attention's implemented. So what's the next thing we do now? So we've done the scale. We've done the map mult. We need to do the mask next. And we want to do an easy mask here. Similar to what we did in PyTorch with Python. Where's that at? Where's that? Transform by transformer. We want the transformer file. Here we go. All right. So what do we call that? We call that the mask. All right. We need this in Python and using Rust. So let mask equals, right? To do define once. You know what? We should do that. We should do that right now. Let's just do that now. We'll do that right now. Okay, so this will be TCH NN transformer, generate mask, and then we need the size. Okay, so this part I'm not... Oh, no, we cannot because it might be a different size. We cannot do it the way I wanted to. All right, that's fine, that's fine, that's fine. We'll do it here. Fine, you guys, fine. We'll do it here. Okay. Let's see if that works. Okay, so we need to figure out what this is here. All right, so it didn't like the size. Size, self, vect. All right, how do we do this? Unexpected argument of type integer. Yeah, that's what it's supposed to be. It's supposed to be an integer. Okay. So let's look this up really quick. Let's see. TCH Rust equivalent. Yep, looks good. Okay. Oh, isn't there generate square? So wait. I mean, I suppose we could do this. Isn't there? It's built into the Torch framework. So isn't there? Can't we do this? I want to do this right here. This. All right. Let's see. TCH. What's your Instagram pub number account, Steven? Oh, good luck, givers takers. Yes. All right. So that would be Instagram. Go here. Profile. Here you go. Stephen Blum code. There you go. Stephen Blum code, giver takers. Let me see if I can copy that. Copy that. Here. I probably type that in. There you go. There you go. Stephen Blum code. There you go. Yep. And you'll see different. So I do post reels there on Instagram, and you'll see different reels than I post everywhere else. Sometimes one or two reels will show up that are the same across platforms. However, I do allow every platform to have different reels and different shorts on YouTube. So they're different. So if you follow me in all the places, you're going to get different reels and different shorts. There are only two competitors in the US and China, and only because they own lots of data. Wait, which competitors are you talking about? What do you think of next steps in Python? Which competitors? All good, I appreciate and your work. Good luck, givers, takers. Thank you. That's nice for you to say. I appreciate it. No. Rust, yes, okay. Do we need to build this ourselves? I mean, I suppose we could. It's just that it should already exist. Is there a... Yeah, and TCH Rust. I'm pretty sure... Did we have this here? Okay. So let's see if we can search for it. Well, not Stephen Blum code. Let's try this. Alright, is there such a thing? How about tensor? Okay, there's a tensor. But there is no generate square subset mask, a subsequent mask. Okay. If that's the case and we have to write it ourselves, then let's see if we can write it as simply as possible, right? Let's create a really simple function that does this. I want a simplified version. So I think we saw a pretty clean one in here. Where was that at? No. Is this the right one or is it this one here? Here we go. That's in Python. Okay, so see, there's just too much. It's just too much for what it is. I need like a cleaner, easier version. We could type all this out. I just don't want to. Let's see. All right, so shorter, cleaner, mask, causal or some whatever. I need a quick, clean, easy one. Okay. Isn't there can't we do like an I or something? Causal mask generates causal mask comparing index row greater than column. Let's see. All right, am I okay with this? Think causal mask device. Okay. Should we also store the device in our tensor? Probably. Okay, let's try this here. Device. Where do we have that at here? Source, main. All All right, device. Okay, it is here. Now we need to start indenting this. All right, and let's add a device. Go. Okay. Transformer device looks good. Okay. And then we'll have a bunch of blocks. Do we also need a device reference here? I don't know. Do we? And do we need the VStore? We probably need the VStore as well. VS in the transformer, and we're going to call this a path. Do we have the path defined here? Yeah, we did. Okay. All right. Let's see here. Where did we leave out? Okay, so we're doing the mask next. So we need to define another function around here somewhere. Here we go. How's it going there, Selvin? Selvik, how's it going? I always wanted a software engineer. How become chemical engineering? Ooh, but enjoying the show. Thank you, appreciate it. Good to have you here. Chemical engineering is, I would say, very challenging. Because it's a real world and there's danger. When I'm typing on the keyboard, it's me just sitting here typing on the keyboard. It's a lot easier. Thank you for the hearts, appreciate it. Okay. So what do we do here? Oh, we just moved that around. Okay, so we moved that around. So we got our embedding, we got our structs, and then I want to add in another function called a fn. This is going to be causal mask. We need to, let me get the music going here really quick. All right, is that it? Or will the next song appear? No, we got to go to the next page. Okay. Here we go, getting the music back on. Boom, easy, okay. What do we need? We need the size. We basically, because it's going to be a square, I think, right? Basically it's a square because we did a mat mult. We just need the size. 64, and it's going to return a tensor. Size, and do we need the device as well? Maybe we do because this is a mask. Though if we implemented this directly inside of our transformer, then we already have the device. So we could implement it inside the device. Do we need to, only the mask in the block, right? So we could just add it here. Just realized there was a live subtitles. Nice. Oh yeah, thank you. We wrote this 8 years ago. Yeah, this is real. We wrote this. It's some software that we wrote many years ago. It's really nice to be able to finally use the live subtitles. It's really nice. All right, so what do we need in here? We're gonna return, I'm just gonna type all of this out so that way I get like a general idea. Negative infinity, yes, okay, negative infinity. All right, so let's type this out, you guys. We don't need the device because we have it. Hey, oh, CT, thank you for this, thank you for the, what is it, chili? Thank you for the chili, appreciate it. That's really nice for you to do. My gratitudes to you. That's so nice, I appreciate it. Thank you for being here. We're just building ourselves some chat GPT is what we're doing today. That's what we're doing. All right. Tensor A range, which is going to create, I believe it's not a line space. Well, it is. It's going to create a whole bunch of numbers in a row, in incremental numbers, right? So we got our size, and then we need to say kind float, which is an I32. No, it's an F32. And then self.device. This is in the device. Yep. Oh, wait, you forgot this. And self. There we go. A range device. Let's see here. I need to be able to see the screen better. Then arrange. There we go. Perfect. Perfect. That should actually just work. I should be able to compile this. Let me fix this over here. Where was that? Mask. Okay. Was this actually not a function? Pub function size. Query. Query is a tensor though. You were saying competitors for AI race. Oh, right. Yeah, they're definitely competitors. Good, Rox, thank you. Yeah. Open source versus the studios, right? The AI studios, the AI labs. So you'd think that that would be an error, but it's not. So what if we just said like 10? Unknown field. We didn't save device. Transformer. Where do we... Oh, because I'm in the block. The block doesn't have a device. Suppose we could add the device here. Block heads. The device. Do we want the... Don't we need the VStore as well? We need the VStore too. You would definitely like to learn how to write code. All right, that sounds great. I'll try and learn one day. You can do it. It's a lot of fun. It's a lot of fun. Well, it's also really frustrating. At the beginning, it will be, and for the rest of your life, it continues to be frustrating. However, good news, you get better after a while. You do get better. Heads, dimensions, to do, define once. Oh, we don't need to do that anymore. Okay. Let's see, where are we at here? Okay. We're looking good. Things starting to get complicated. Transformer VS. We also want the VS here, maybe. I think we do, right? Okay, because we're going to have some things that we're going to want in there. So the transformer is going to need a VS and a... So I also need VS and device. So let's grab this here. Transformer block. Got our heads. We also need our device. Maybe a device. And then, do we call it VS? We call it VS. Do we want to call it anything else? I think that's fine. I think we know what that means. VS, device, heads, and dims. VS, device, heads, dims. Looks good. Okay. And then we need to... So if we have a tensor, okay. So... Where are we at now? All right. Unsqueeze to... What that does is it removes a dimension at the inner dimension. Right? Causal mask. And we can say dot unsqueeze. Dot unsqueeze at number 1. Okay, let's see if that works. All right, let's get this can compile. Transform. Oh, that's why. Okay, I was wondering. All right, I was waiting for that. Okay. Kind not declared. We can fix that. Actually, isn't kind just straight up here in TCH? Find out here, you guys. All right, there we go. Looks good. Also, it's asking us to do lifetimes now. Oh, nope, we're not gonna do it. We are not gonna do it. I don't think so. Not even a smidgen. I don't think so. Nope, not gonna happen. Where's our path again? Okay. Expected named lifetime parameter. No. Nope. I don't think so. It's not gonna happen. I don't think so. We went on the transformer. All right, device path. Here, let's see what we did wrong. Let's see, because I know we don't need to deal with lifetimes here. Well, all right. Let me see here. Do we store? Yeah, because we need to store it. So VS is... Oh. So maybe we won't store the VS. We just always include it as a... I just want the reference to it. What's lifetimes parameter like in static C? Like in statics in C++. So a lifetime, as far as I understand it, is pretty native to Rust. It tells the compiler how long data is to be. Hey, Medi, thank you for subscribing. Welcome on in. Good to have you here. You joined the right channel for software engineering. Good to have you here. We're building a chat GPT today, is what we're doing right now. Lifetime parameter in static C. So as far as I understand, lifetimes I've not run into in C++, at least in my existence. And it's kind of like static, yeah. So you could think of it like how static though is scoping, right? So if you define static in a higher scope or lower scope, it's always going to give you the same reference to the same variable, even across calls between function calls. So basically it's like declaring a global, but it's not a global. It's a global in terms of its memory is permanently fixed. With a lifetime, it's not like a static. A lifetime just says how long Rust needs to keep this in memory for, but it's not a static, right? There is static in Rust, and it's also the same, I believe, as inside of C++. Okay, I want to save the VS. Maybe we don't need it. Maybe we don't need to save the VS. That's something that we might not need to do. So let's not save the VS. And do we need the device as well? I also don't know if we need to save the device. So let's not save it. So embedding, yeah, okay. Path, yeah, we need to have it there. We need to have the path there. But we don't need to save it. And device can be device, it doesn't really matter. Hey, I knew it! There we go! Oh, cool. Yeah, it's pretty neat. It's pretty neat. I'm satisfied with that. Okay, we're looking good, you guys. All right, let me check my calendar really quick. Where are we on here? Okay, good. We've got some time. Hold on. Did I see a message just show up there? What is this? Oh. Double check. Okay. Deal with that later. Okay, you guys, let's get going. All right, so let's finish out the attention. Let's see if we can do the attention here. We need to finish out our mask implementation. All right. I don't know. What is this? I don't want to just use something and not what it is. TCH Rust. What is this? This is LT. LT is what? What does LT do? What is LT underscore tensor? What is LT tensor? No, what is this? PyTorch, LT stands for less than. Oh, got it. Okay. Yes, I understand now. So this is a conditional that's going to apply to every single element in our tensor. And if it matches, it's going to return different values. Although we can say it's going to return the number itself or infinity, which is what we're currently working on right here. Right. So the device or itself. Okay. So we're creating a... Let's see. What's SZ again? Oh, size. Right. Okay, right. Because we're creating a square. Okay. Kind float device, mask fill. Is there... I'm wondering... So here, I'm just going to copy and paste this. And I'm wondering... Here, let's hide this. Okay. Let's see. Shorter, simpler. All right, let's see if we can make this even shorter and simpler. Trill. There we go. That's what I'm looking for. Okay. I like that. Okay. No A range matrix ticks uses trill. Trill. That's what I'm looking for. Fewer lines done in a clean chain. Trill. Yes. Okay. Here we go. Much better, you guys. Much better. Mm-hmm. Okay. Okay, perfect. Okay. So this creates an upper triangle with trill, flips it to a lower triangle. Cool. Okay. So we don't need to use A range. Let's use trill. So we're going to do ones. Same as size. Although we need to give it a slice here, I guess. So it's going to be, right? Instead of before, what we were doing is we're creating a range, which is going to create, a vector. And then inside the vector, we were creating another vector. So this creates, a matrix, a 2D matrix. Instead, if we just use ones directly, we can create the 2D matrix on one line of code rather than a couple. So that cleans it up. Then we can say dot trill at the 0 dimension, right? So the first dimension, it's going to create a diagonal triangle, basically. Well, a triangle. It'll create a triangle. Diagonal triangle. So the lower half is going to be zeros, and the upper half should be negative infinity. I think that's what that is. Or ones, maybe ones and negative infinity, something like that. Mask fill. Here we go. And we want that to be a... Oh, let's see here, 1 second. Is this the right? Yeah, okay. All right. Okay. So let's type this out. Ampersand tensor zeros. And it's going to be an empty 0. A float device. Okay. Then it needs to be negative 60. Okay, so F64 negative infinity. Okay, I think that's it. Did that get us what we wanted? Did I say self-device somewhere? Oh, right. Okay. Yeah. Do we have the device? I think we do. I think we have the device. Did I not save it though? Yeah, I have it right here. It's right there. Oh, here. There we go. Okay. Unexpected token. Because we are problem. There we go. Perfect. All right, we're making it good. Input.device. Oh, 8 rocks. Input. Oh, that would be good. I see what you're talking there. Yeah, because then we can just keep it based on the input the same, right? However, in our case, this is making just a mask out of nothing, so we don't have input, so we have to go based off of ourself. I like what you're doing, though. That is a really good approach because it just keeps track of whatever device is currently being acted on, and it will create a similar, it'll create it on the same device. All right, so tomorrow, I think we're going to build the graph tomorrow. Okay. So let's get our causal mask here real quick. Okay. Causal mask looks good. Yep. Forward. Attention. This is on our block. Wait, where's our attention at? Oh, it's just down below. Okay, there we go. Okay. So we've got our mask. We're good. Now we're going to continue our attention. Let mask equals self dot causal mask. Then our size is going to be query dot size 1. Let's see if that works. Did we size I64? Yeah, that's right. Isn't that what I wanted? Expected got a vector of I64. Do we say dot item? Can we do that? Is that a thing we can do? No. Oh, iter. Okay, no. All right. Thank you for the hearts. Appreciate it, you guys. All right. So we need to figure out how this works. How do we get just the I64 What is it? Because right now it's returning a vec device 64, which is helpful. Actually, it is helpful. I just want the first element, I think, right? Let's do that. I don't know if we can slice it. No. So this is where I would like to see. Oh. Ah, really? All right. Well, let's try this. 1. Okay, there it goes. We just took the slice and it works. All right. I don't know if it's good or not. We're gonna find out. All right, so we got our mask. What do we do next here? We did that. So we need to create a softmax around that. So out equals. Let me see really quick. How do we apply the mask in Torch in libtorch inside of Rust? Do you guys know? All right. How to apply mask to tensor? Let's find out. Yep. Oh, you just add it? Out plus mask. I think that's what we did as well in our torch. Here we go. Oh, we had a function. Okay, yeah. So we've got a function that does that for us automatically. Okay. Run. Out, mute. Let. I have to mask it. Hold on. Let. We have to shadow. We have to do variable shadowing, you guys. All right, good. Looks good. Okay. Got our mask. All right. We're almost done doing attention. So now we need to do a softmax. So can we say TCH softmax? Is that what we can do? Not found. All right. What about neural network? Not found. All right. Where is that? Where is it at? TCH softmax. I know it's around here somewhere. I know we've seen this. Soft. There's a log softmax. Oh, it's available inside the tensor itself. So we say just dot softmax. -1. Data type. What? Why? No! Kind float. Be that way. Be that way. Okay. All right. We did it. We did it, you guys. So we could also add a dropout. Do we want to add the dropout? Yeah. The dot dropout. Can we do that? Dropout requires the same thing. All right. Fine, if you want it. All right, you asked for it, you're gonna get it. You asked for it, so you're gonna get it. There you go. Wait. Oh! 1. I suppose we could make this a hyperparameter, right? So let's just say, drop out. F64, maybe? Hey, Crafty, good to see you. Welcome on in. Happy Wednesday. Wait some time, then I got crown. You got a crown? Crafty Anime, what does that mean? Hey, everyone. Good to see ya. All right, transformer. We didn't implement it, so we're good there. But our block wants it as well. So do we want to throw that in our block? I think we'll put that in our block. We'll put that over there because we're gonna have more than one dropout. So, right? Might as well. Okay. So tomorrow we're gonna define the graph. Yeah, drop out. And this is gonna be an F64. Next time, Crafty, enough code for today? Enough code? Oh, so much code, you guys. How's it going there? And Kit, good to see you. Hey, Steven, hello. Welcome on in. My summer vacation's over and I have your exams day after tomorrow. Good luck. Good luck. My eyes want to close, sleep, but don't want to miss stream. Hey, Crafty, we're about to wrap up, so you can close your eyes here very shortly. Crowns means XP. Number 1. Oh, got it. Where are you, Crafty? All right, you are at 150. At 150. That's pretty good. Doing pretty good. Let me see here. Go back over here. Okay. Yeah, doing great. Okay. So where did I miss out? We need to have the dropout. I believe dropout is going to be right here. Dropout. All right. Did we get it? Are we good? Everything happy? Transformer blocks got the dropout. And our transformer doesn't matter. Although this is the main entry point. So yeah, there's that. I feel like dropout should be up there. I feel like it should be up there. We'll put it up there. We'll put it up there. We'll make it up there. We'll do that. We'll do it. Hyperparameters, you guys. All right. Heads should be a tensor. Do we want to be a tensor? All right. All right, we're good. Okay, good. Okay, dropout. Wait, what? Did I make this a function somewhere? What is that not good? Okay. Self P64 train. Got it. Let me see here. Hold on. Dropout. Here we go. Is training on the forward. I understand this. Oh, Minefield Daily, good to see ya. All right, have a good rest of your day. Minefield Daily, thank you for saying hi. I like what you guys are doing there. You're doing the OG emoticons, right? OG emoticons. When they were text before we had real, like, you have the crown. Oh, you do? Do you really? Wait. Let me check. You crafty. Oh, you're number 1. Look at that. Good job, Crafty. How'd you do that? How did you do that? That's actually a really good question. How did you manage that? Good job, Crafty. I don't know how we're going to deal with this. All right, so I know this is a Boolean. Here. We need to figure out how to deal with this. To do drop out the is training. We need some sort of is training on that. This is kind of annoying because it should automatically know that based on the graph if we're not creating gradient, right? Because we are in a different mode. In PyTorch, it lets you say eval mode or training mode, and it's automatically carried over. Here, we have to track it separately. I guess we have to track this separately. So we'd want to add that here. Training is a bool. So this is a to-do, a really important to-do item here. All right, for dropout. There we go. Will prompt this model. Oh, wait, I want to see how fast it is. Me too. It's not there yet. It's going to take us a few days. It will. So we're implementing it one by one, and the implementation, even though it's compiling, it might be wrong. Like, we might have to fix it. We might have to do various fixes along the way. You're not spam chat face emojis like this. See how cool it is, right? That's the way to do it. I guess you figured it out. Okay. So I'm happy with where we are right now. Kanji emojis. Yeah, kanji emojis. We did we finish our attention? We did. We finished our attention. Let's do self.training. Let's make sure we're good here. I'm just gonna do this now. We're just gonna do this right now. There we go. Okay. Also, how about we do this? There we go. A little bit cleaner, a little bit cleaner. Meow. Yeah, got the meow. Thank you for the hearts, you guys. Appreciate it. All right, so is that it? Yeah, we did it. We did it, you guys. We just implemented attention's all you needed right there. Where we go? There we go. Kanji emojis are more fancy. Ooh, even more fancy. Ooh, like this. Whoa, no way. That's cool, Torva. I didn't even know there was such a series like that. GG. Hey, Parker, thank you. Appreciate it. Can you explain the computational graph that we will be doing tomorrow? Yeah. So we need to define. So I'm not 100% sure, but we've got our tensors here, and we need to create. These are the outputs from the projections. So we have to create our projections. So where is this at? Oh, la, 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 la. We have to do this. We need to define this part here in the middle of the screen. These are linear layers. This is just, you know, more work on those tensors, more math on those tensors. We didn't do multi-headed, so we have to do that as well. Then we need, this is part of the graph here, right? A feed forward MLP with activations. And then also part of our graph is another linear layer for the output projection. And we have to do norms. We have to do some norms here to stabilize the graphs. We have to stabilize the graphs. We did our embedding, so that's done. And we haven't done positional encoding yet. We'll see if we can do an end-to-end tomorrow. I think that'll be planned for tomorrow. Not even close. Technoblade. Oh, Technoblade never. Oh, yep, exactly. Who remembers? Minecraft. Yep, I remember. He never. Exactly. Alive forever. Quick fix. You got it. Technoblade, you guys. I remember those videos. Okay. So here, where are we so far? So we've gotten our tokenizer. We've done the embedding. We've got the output from the embedding. We have not done positional encoding yet. We haven't really done a feed forward yet, so we haven't really queried and valued it yet. We have not done the projections. We have done the softmax attention. We have done the attention. We did this. Attention is all you need. We did that part. That part's done. We need to do multi-heading and then feed forward in the norm. So we've got a lot of work ahead of us. Dr. Dubbed. Oh, yeah. No, oh, wait. I forgot. Oh, wait. It's been a while. Dr. Kanana. Auto completion. Yeah, I know, right? I know, right? All right. So that's the plan for tomorrow, you guys. So let me make sure that this still works, though. All right. We need to we're going to finish this really quick. Training. So this is inside my transformer block. And then we're going to say training. How do I want to do this? This is really annoying to have to propagate this down. It's like really annoying to have to propagate it down. Because how do we turn it off? I suppose we're going to have a different mode. So we need to see. We'll say true. We'll say true by default. Training. Okay. It's right there. What do you mean? Training, self.training. This is in our transformer. Do we have it in the block? Though we don't have it in the block. Okay. All right. We did it. We need to add like a training or an eval mode, which is it's not a problem. We can absolutely do it. It's just we have to remember to set these, and then we have to iterate through all of our blocks to do it at the same time, right? I suppose we could implement some sort of fetcher, though. Some sort of easy fetcher. Okay. You know what? We'll have to do this later. We do. To do implement better function for a training and an eval. All right, so we have to do that as well. Okay, Steven, what do you think it's already? Should I sleep or do some of my studies? Sleeping is always really critical, so definitely get sleep because it makes your brain work better, right? You do dropout when you're sleeping. You do some dropout. We're talking about dropout here. Dropout while you're sleeping, and it helps get rid of things that are not important and remember things that are. So sleep, study in a cycle. You want to do it like that. You guys are getting fancy. You guys are getting fancy. Okay, 68. There we go. Get add, get status, get commit, AM. Added attention. We need to multi-head, which is just a view change. So it's a view change. Dot view, or like a reshape. So we have to do that tomorrow. There we go. Boom. Life while loop. Never stop forever. Exactly, right? That's the way to do it. All right, guys. Thank you so much for joining. Had a lot of fun today. We built our attention's all you need. We fixed our tokenizer. We did a lot of things, you guys. We did a lot of things today. Look at this. We wrote our own attention algorithm directly in Rust. Right there. Right there, you guys. So good. I don't know if it's gonna work. Until come die, right? I know, right? And then it's like loop while awake, basically, right? While awake. Until awake. And have you seen FIFA World Cup? I've seen it on a TV screen. Yeah, I saw it on a TV screen. I did. For a brief moment, I saw it. It's happening right now, you guys. The games, they started. The football, the soccer. All right. Good to have you guys here. Thank you so much for joining. We'll continue more coding tomorrow. So we'll be doing more Rust transformers tomorrow. The plan is we will implement the graph itself, which is going to be, our actual linear layers, the parameters. So we need our projections. We need our feed forwards, which are going to be the blocks. And then we need our output projection. Our input projection, output projection, and then our feed forwards. And I think that's it. That's it. That's really it. I think that's it. Yeah. And then we got to train it. Let's meet tomorrow. Bye-bye. All right. Sounds good. Thank you, guys. Thank you, Rad Kumar, for staying. Thank you, guys. To have you here. Take care. See you again. Sounds good. What's your fave movie? Well, Contact. I'll say Contact by Carl Sagan. All right. There we go. All right. Thank you so much for joining, everyone. We're headed out. See you guys tomorrow. Have a good rest of your day. Enjoy. And we will be back tomorrow with more Rust and Transformers. We're building ChatGPT, you guys. See ya. Well, it's been a pleasure, everyone. Have a great rest of your day. Thank you. All tune in next stream. All tune in next stream. Perfect. Thank you. Hey, there we go. I love it. I love those. Thank you, guys. Bye, everybody. See you tomorrow.